We are going to be talking more about matrices. By the end of this lesson, you will know more about determinants. Hey, what is a determinant? A determinant of a matrix is a scalar that can represent a matrix in calculations. Determinants can only be calculated for square matrices, and they are very useful in the analysis and solution of linear equations. Determinants are also important when finding the inverse of a matrix. If we have a matrix A to be this, the determinant is written as det A with a modulo, or det bracket A. Also, the determinant of a matrix is enclosed in straight vertical lines and not brackets, as we have in ordinary matrices. There are various ways to go about finding the determinant of a square matrix, but we will adopt one, the Laplace expansion. To find the determinant of a 2 by 2 matrix, subtract the product of the elements of the second diagonal from the product of the elements of the leading diagonal. So, if we have a matrix Z to be this, the determinant is AD minus BC. For a 3 by 3 matrix, the story is quite different. First, pick the elements of the first row and then write them out with adequate spaces between them. So, we write A, B, and C. Now, we will shield the row and column with A on it. The remaining 4 elements form a 2 by 2 matrix. Write the determinant of this matrix just next to A. Now we move to B. Shield the row and column that have B in it. Then write the determinant of the 2 by 2 matrix formed by the remaining 4 elements after B. We write a minus sign before B. The reason for doing this is beyond the scope of this lesson. For C, we will do the same. Shield the column and row bearing C. Get the determinant of the 2 by 2 matrix that is formed by the remaining elements. Write this just after C and write a plus sign before C. This is the determinant of the 3 by 3 matrix. We can go further to simplify the process of finding the determinant of a 3 by 3 matrix to have A bracket open, EI minus HF bracket close, minus B bracket open, DI minus GF bracket close, plus C bracket open, DH minus GE bracket close. So whenever you have a 2 by 2 matrix, you can use this formula to find the determinant. To find the determinant of a 3 by 3 matrix, use this formula. Another thing you should hold on to about determinants is that if you multiply the determinants of 2 matrices, it is equal to the determinant of the matrix gotten from multiplying both matrices. It may interest you to know that a matrix whose determinant is equal to 0 is called a singular matrix. Also, the determinant of a 0 matrix is equal to 0. So we can say that a 0 matrix is a special case of a singular matrix. Unlike the singular matrix, the determinant of any identity matrix is always 1. Determinants go further than we have discussed, but we will stop here for this level. In summary, we have seen that the determinant of a matrix is a scalar that can represent the matrix in calculations. We have also learned how to find the determinants of a 2 by 2 and a 3 by 3 matrix.